So you have
Basically, if it's okay,
yeah,
yeah.
you have to find the subarray. Means you have to return true or false. Means you have to return that is there any subarray present with zero sum or not.
Right. So you do the subarray, and then the subarray is when you add each index together, right?
Hmm.
And then you see if there's a repeat or if there's a zero value in the subarray, right?
Yes.
And then based on that, if there is, then it's true, and if it isn't, then it's false or zero sum,
Okay.
right?
Yes. So
Okay.
zero sum, right? For you have to find the prefix sum, and you have to check every time that same prefix sum is repeating or not. Means if there is same uh, means prefix sum is coming, that means inside somewhere there is a similar means zero present sub sum. So so let's say there are multiple subarrays present. So if till this point, if subarray till this point the subarray sum, prefix sum, and both the prefix sum, let's say two subarrays you have, this subarray and this subarray. Both subarrays, if the prefix sum of the both subarrays are same, that means that in between sub subarray has a sum of zero. That's the condition. And another thing we have to check that if another condition we check, can you tell us? Tell me.
Right. You check if the. I mean, I the repeat, right? Or
If
ask for another
repeat
one.
is one thing, and another thing is if prefix sum itself is zero. If prefix sum
Right. Right.
itself is zero, that also give us true. So this
Right.
is the two conditions. Okay. Now that is for zero sum. Now the question comes if there is a target sum given to you.
Okay.
So you have to tell us, tell me that if there is some subarray present with a given sum or a target sum given to you. So let's take an example. Uh, 5, 8, 6, 13, 6, 13, 3 and minus 1, and your target is 22. Your target is 22. Yeah. Now tell me, start from brute force, and then
Sure. Sure.
we'll.
So, hmm, I mean, for brute force, you can check with a hash map, I guess, right?
No, hashing comes as optimized for optimization.
Oh, okay.
Prefix sum mostly used with hashing, not
Right. So,
always, but mostly used. But when I say brute force and knife, it's very intuitive. So you have to find all the subarrays. You have to find all the subarrays, and then you have to check if the sum is same or not. So I am writing the template boolean is some or something like that. And I am passing the nums array and a target called k. Hmm. So now you have to return true or false. So if I write the can you try to write the brute force? So what is see every Savaré problems the brute force will be finding all the Savaré possible in that array. That will be the brute force always. So if something comes in the interview and they ask you like any survey problems, they ask you like, if let's say if some solution is not coming your head that time, so first tell them that see survey means we have to find all the possible surveys, and then we have to
Okay.
just checking that conditions whatever condition is given in the question. So that's the concept. First you have to find all the surveys. That's the naive or brute force. So finding all surveys is n squared, and then
Okay.
some checking is, if checking is something there, then let's say another n is taking, so n cube, some possibility is n cube, something you can do n square. So in naive approach or brute force, the best you can do in n square. So if you can do this with n square, you have to find all the subarrays. So there will be a start pointer. So how this brute force coming? So what is the brute force is doing? So we have two pointers, let's say I and j, starting from at the same position. So what is doing, we fix one pointer, and what we do, j is moving every index and till the end. And when j is moving, so let's say j I is at 0th index, and j is, let's say in the second iteration, j goes to one index, right? It's 0, 1, 2, and 3. So when j is going to one index, so 0 and 1 becomes one subarray. And when j is going to
Right.
two index, that 0 to 2 till this is a subarray. And when j is 3, this goes to another subarray. And this is for first iteration for I. Then I move to next index to 1, and j starts from again the same index. J is equal to I in the inner loop. Okay, so j starts again from I. So 1 to 2 is another subarray, 1 to 3 is
Wait,
another.
real quick.
Yeah.
So in this problem, like this method,
Hmm.
if the answer is the sum of 1 and 3, then how would it be possible to do it?
1 and 3 means, can you tell me again? 1 and 3.
Okay. So if it's like you need to find 10, right?
Let's say 10.
And
Yeah.
then this is 4, and this is 6, and this is like 2 or whatever, right? Then how do you get 1 and 3?
No, no, we cannot do that. It's subarray. Told you last day.
Oh, right.
Subarray and
Contiguous, right?
substring is contiguous, always contiguous. This is a
Okay.
subsequence problem. There is some problems are there. We can solve that. So sometimes we have to short that sub for subsequence, not subarray. We now consider only subarrays. So this is not possible in this case,
Okay.
this algorithm.
Okay.
PrefixSum for sure. Yeah. So now you have to write the brute force one now. So always remember subarray is contiguous. So if something comes like this example, then always return false.
Okay.
So now the target will be two for loops, and you have to find all possible subarrays, and then you have to check that the desired target is there or not. And desired target, yeah, desired target means the summation. This target is basically a sum. This target is basically a sum number. A number is given to you. Target sum. Let's say I'm.
Okay. Um, okay. Uh, can we, is it possible to skip to the optimized solution?
Sorry, offline solution.
The optimized solution. Can we just like skip to that instead of the naive one?
Yeah. Okay. Sure. But I am writing this. No worries.
Okay,
Okay.
sure, yeah.
So yeah, for now, what we do? I started from 0. I less than what? I less than nums dot length I plus plus, right? So
Right.
sometimes basically they ask, so that's why. And most of the
Sure,
survey
sure.
problems, naive approach is almost similar. So int j equal I, j less than what? J less than nums dot length,
Just outline.
j plus plus.
J plus plus.
Hmm. So two loops. I is basically start index. On let's not remember, start, and J is the end index, denoting pointing to that. Now what we'll do? We will create another variable, and let's say summary is there. Let's say current sum. Current sum is initially is 0, and car sum equal car sum nums of j. Right, we are finding all possible summations for every subarray, and if car sum equal target sum, return true. Return true, or else return false. At the end you can return false. So after all this iteration, return false. And we will miss one point. So every iteration the start pointer, we have to reset the count, reset the sum. So
The
car
target's
sum
first sum. Yeah.
equals 0. Then for the next iteration it again start. So this is how the naive approach, and it's n square solution. Yeah.
Okay.
Yes. So if you carefully check, mm prefixum is correct or not? 5, 13, 19,
Uh,
32, 35, and 34. Yeah, fine. Now tell me, can you find some target sum 22?
no.
No, 30. See, 13 and 35.
Um,
So if you subtract
okay.
13 to 30 from 35, it gives you 22. What does that mean? That means from 13 you are subtracting, right? So from 6, 13, and 3, if you are taking this subarray, it gives you a sum of 22, right? So
Right.
the logic comes from here. So
Oh, I see. Kind of.
you have to means you have to subtract the prefix sum, and means you have to subtract some two pair of prefix every time, and you have to find the target sum is there or not. And when you are subtracting prefix sum, some prefix sum, that will be the next. So the index starts from the next index basically. We are not finding the target here, but yeah, we just return true and false. So yes, so you have to find the prefix sum, and you have to subtract one prefix sum every time, means another prefix sum from that current prefix sum, pre-calculated prefix sum. So from current prefix sum, you have to subtract the pre-calculated prefix sum. You understand, right? So
Yeah.
you have to traverse that array. You have the prefix sum with you. So see another thing, prefix sum you can calculate in the same iteration or a different iteration. Means you can take another for loop to calculate prefix sum and store somewhere. And another way is, means that's a naive way I can say. See, you are taking another iteration and store prefix sum somewhere, another array. That's take it takes an extra space, but we are doing in one iteration. Okay, one iteration. Sometimes in the interviews, interviewers ask like, can you do in one iteration? Let's say, yeah, two iterations also give you same time complexity. But yeah, they they ask you like, can you do it in one iteration? Can you somehow reduce one loop there? They ask sometimes. Yeah.
Right.
So that's why you have to first try to understand if you can take another array to store prefix sum. That's one case, but we are doing in same iteration. That's the trick. Okay, so first iterate the loop. I am telling you how to do that. First
Sure.
iterate to do.
Do you want me to type it or?
Yeah, in the
Oh,
code editor.
sure. So I mean, it's basically the same as the top one, right? It's like this.
Yeah, current sum. See, name convention should not be here. Current sum. See, here in the last naive approach, we are not using prefix sum. It's the current sum till the index. So every current sum means every subarray sum, we can say. But
I
here
see.
we are taking prefix sum. So the name should be prefix sum always. So naming is should be correct.
Okay. Uh,
So that is also checked during interviews.
okay. So prefix and then make a hash map, right? Or you said hash set.
Has said.
Okay.
Why?
So
Why has said?
uh, I'm not sure. I forgot. Yeah.
See, has said first of all. What's the features of has said? I say has said contains only unique elements. It removes the duplicate, right? You know that.
Right.
That's one thing. Has said when we check has said we can check the uh, we have a method called contains that gives you lookup time as constant. Like in hash map, also we find the get method. Here we have contains method. So
Right.
that gives you lookup time as one. So but it's constant time. So that's why we prefer hash set.
Hash map has the contains key, right?
Contains key is there, yeah. Contains key is there. Contains.
So
Uh,
what's like it contains. So why is contains better than contains key?
Not better, I say. Means here we do not need hash map. Otherwise, we will use hash map because I told you the most of the prefix problems use a hashing. Hmm?
Right,
So
right. But why do we not need a hash map?
here, right? So we are not storing key and values here. Anything. Can you, if you go to the problem statement, so we are not finding. We just return true or false if there is some subarray present. Let's say I am asking the length of the survey. I am asking the length of the survey. What do you have to do? You have to store the prefix sum as a key and value as a index in the
Right.
map. In that case, you need a map because you need the index as well. Otherwise, how can you find the index of that prefix sum? So in that case, we need a hash map. So that's your homework. So you have to find the survey with a given sum. Um, Subarray length of a given sum. Hmm?
Okay.
That's a home
Yeah.
task. So you need that time a prefix, hash map because you need the index there. But here in this problem, we do not need any index or anything to store as a value or key. So it's simple that you have to. It's simply you have to return true or false. So in that case, we do not need to store anything or for further checking. So that's why we are not using map. So you have to understand that map gives you benefit where you need the key and value pair there. So you can store something useful, but here we are not storing anything. So that's why we are not using map. Okay.
Okay.
So now in prefix sum of zero, what we did in the last problem, we did prefix sum minus zero if that is present or not in the problem
Right.
in the Savare. Prefix sum zero for zero sum. Now we have to find prefix
Prefix
sum
sum
minus this
target
target
sum.
sum, like two pointer problem. Sorry, two sum problem, right?
Right.
Similar kind of problem, but there is some twist here. So prefix sum minus target sum. If that is present, that means 35 minus 22 means what? 13. 13 is present. That means you give true. Sorry, you
Right.
return true. That's the main intuition behind this problem. So
Right.
in this problem, last problem was prefix sum minus 0, but here we change the prefix sum minus target sum. So that's the problem. That's the intuition. So you can write this code. Simple.
Sure. Here.
Yes.
Okay. So we'll do a hash set. No, I might be declaring it wrong.
Set.
The set, right? And then
Set. Yeah.
integer,
Integer.
or,
Hmm.
and then we'll say uh,
Eh,
pre pre sum set.
yeah. Any name. Yeah. That's fine. New has set.
Right, right, right.
Yeah. Fine.
Right.
Hmm. Yes.
Right. So then, basically, you can do pre sum plus equals I, not I, sorry, noms I, and we'll do
Yeah. That's fine.
pre sum set dot put uh, dot put the pre sum, and then put if pre sum set that
If
contains
contains of
pre
if sum minus
sum
target sum.
minus target sum, return
Return
true.
true, or after this
Then
loop at the end you have to return false.
right.
Still there is some issue. I will come that point.
Okay.
Have tell me First, tell me that prefix sum put. Why did you put this line at the end? Means, can we write this before checking this if condition? Can we do that? And if we do that, what will be the issue?
So you can't do that because you're putting if you put it before the contains pre-sum minus target sum, then the
It will be always true, right? It will be always present in that case. So if we write this prefix sum, sorry, this means we put this. We sorry, put is not there in set. It will be add.
oh, okay, yeah.
So if we add this in the set before checking the condition, what will happen? So let's take an example. So it will always be, it gives you always true. How? Let's think about with an example. So let's say 5, 13, 19. These are the prefix sum, right? So before putting inside the hash set, what we are doing, 35 minus 13 we are checking. Sorry, 35 with 22 we are checking before storing the 35 in the set,
Right.
right? So after
Yeah.
checking this, then we are putting the current prefix sum in the set,
Right.
right?
Yeah.
We do before that. If we do before that, what will be the issue? Or there is no issue?
Uh, yeah, I'm a little confused about the issue.
Yeah. So try run this code once. Okay, and let me know. Okay. There is another issue that's in the prefix sum of zero sum. The last problem. We have checked one condition. What was the condition? If the prefix sum itself is zero, right?
Right.
Here in this, let's take another example in this case. So let's say one, two. Let me think. One, two, 4, and 7. What will be the prefix sum for this?
So
Let's say
one,
I'm taking another target sum as 3. What will be the prefix sum for this?
uh, one,
Write this.
3, uh, 7, 14.
14, right? If you check the same if condition, so there is nothing, there is no way you can find the target as 0. Sorry, it's target as 3, right? But 3
Right.
is present as prefix sum.
Right.
That means 1 and 2, these two subarray means this subarray gives you the prefix sum of 3. But the same condition you cannot find that, means the logic we cannot find that. So two ways we can do that. Remember, we will use in
Right.
the in all the subsequent problems the same approach. If pre-sum, if pre-sum, you have taken the name as pre-sum, is target sum, then also return true. So what you can do, you can use a or condition here in the same if
Right.
condition, right? Now I'm writing another if condition, return true. This is one way. Another way is, what you have to do first. Initially, you have to, some problems do both the way. So pre-sum dot add this set. Sorry, this set pre-sum set. What you do, pre-sum set, name is quite long. Pre-sum set 0. Why I have put, see, either you check this condition or this two statements. You have to use either of both of, means either of them. So why I have done 0 here? So now 3 minus 0 is present.
I see.
Means
Okay.
so 3 minus 3 is present because 0 is already there in the hash set. So you have to use either of that.
Okay.
Either you check this condition or you have to put this line, this statement. So in the subsequent problems, when you use more complex problems, so some problems you feel like, means you can see some of that we are storing in the hash map an extra index, an extra, what I say, an extra entry, and some of the cases we check this condition like that. We, if the prefixum is already present. So let's take an example. And another important thing to note means mention that in the interviews they ask you to come up with an example by yourself. Like I have given an example. They may ask you like, can you tell me one scenario where you have to check this condition? So that cases you have to tell them that let's take an example of like that. So that way you have to always come up with an example as well, and that's in the interview discussion. Okay. So yeah, you understand this problem.
Yeah. 100.
So this is two most important thing here. Now another thing that's I asked you to dry run this. If I set in the, means if I add at the end or beginning of the condition, what will happen?
Right. If you put it in the beginning of the condition, right?
Can you run one example with that small example 1247?
Sure. So if we start 1247,
Hmm.
is this line included or not?
What I am doing, I am copying and pasting.
Or so is the presum set dot add zero included or not?
It can be included. Yeah, that's fine.
Sure. So we'll say it starts with add zero, and then we get presum plus equals nums I.
Hmm.
So presum starts with uh
Let's take this one. Uh, we just
or,
add before taking this.
sure. So then presum plus equals nums I. So presum would equal to one, and then presum that add presum. So you add one to the set,
Hmm.
so you get this 0 1.
Hmm.
So then if oh wait, so if presum minus target sum, if it contains presum minus target sum, then return true.
Yes, it's not there, so you just run another loop, and for next.
Right. So then we'll get presum plus equals 2, so we get 3, and then it adds 3 here, and then we check if it equals target sum, which it does, so return true.
Yes, in this case, true. Let's say I am not storing here. This statement is not there.
Okay. Um, I think it's still true, right? I mean, for this one.
Yeah, we stored that 3 before checking, right? So 3
Yeah.
we store inside the set, and then what we do, 3 minus 3 is gives you 3.
So I mean,
Let's try
if
run
you
with
do it like
this
that,
example. Let's try run with this example. Better. This example. Just to try, yeah, quick.
which example?
This example, in first example.
Okay, sure, yeah. So start with 5. So presum equals 5. You add 5, and you get this, and then you get uh, it's not there. So next loop is 8. So presum's 13. Then you add that 13 to the set, and then it's not there. So then you do 19. I mean, then you do 6, 19, uh, adds 19 to it, and then it's also not there. So then you add 13, so you get 32, which is also not there. And then you get 3, 35, and then 35 sets, it fits this condition. So then it returns true. So I'm not seeing the issue right now.
Okay. Hmm. Okay. Yeah. Let me check once again. It comes some example. We have to check some test cases. Okay. Try to write down with some example. Okay. In ID you can write it, because this question I do not think is there in lit code. Okay. I need to check with some test cases. But always add for now at the end. Okay. Let me find some
Yeah,
test.
okay.
Okay. Hmm. So another next problem I come I want to I want to move to the next problem. That is, you
Yeah.
have to find the longest subarray with a given sum. Now comes the longest subarray. You have to find the longest subarray. Longest subarray. So there may be with a given sum. So in this case, there is only one subarray is present. So we have, in the next problem, we have multiple subarray present with the same sum.
Right.
Multiple subarray present with the same sum means prefix sum will be multiple. Duplicate prefixum will be there. That means
Right.
duplicate prefixum is multiple subarray with given some same sum means there will be some duplicate present in that subarray.
Right.
There is another problem is there. So total number of subarrays you have to present. Sorry, you have to return
Okay, so the count.
count of the subarrays. So write these two problems. Otherwise, it will be yeah active. So first is find the longest subarray in the same target sum. Write the problem statement. Yeah, write it. Hello.
Yeah, you want me to write? Oh, okay.
Write the
Find the
problem.
longest.
Find the longest subarray having the same sum target sum, and another is find return the number of subarrays present. This is the two problems. So in the second problem, there it's there in the late code. I am not sure in the first was there or not. So this for the second problem, it's this one.
Okay.
But let's do the first problem.
Sure. Yeah.
Find the longest subarray having the same sum. That means there is multiple subarrays present having the same sum. Multiple subarray present means the prefix sum is also duplicate. So let's take an example. Write it. Let's say take an example. H31.
H31.
No, eight. Number
Oh,
eight.
eight. Okay.
Yeah,
Three,
number eight.
one.
3 1 5 negative 6 6 positive 6 then 2 and 2. Yeah. So let's take an example of this subarray, and we have to find the longest subarray. What's the prefixum? First tell us. First write it down. Prefixum.
Yeah, sure. So do 8, 11, 12, 17, 11, 17, 19, 21.
Yeah. See, there is duplicates. 17 and 17. Why? Can you find the subarrays there? Which subarray has same sum?
Sure. So it would be these ones and then these ones.
But why the subarrays are same? Can you tell?
No, because there's a repeat. There's a positive and negative of the same
Positive
number.
negative means there is a subarray of 0 as well. Like the first problem. -6 plus 6 gives you 0. So that is not counted. So 17 and 17 is coming. Right?
Right.
There is this that's a it gives it neutrals the summation.
Right.
Okay. So you have to find the longest subarray. What will be the longest here in that case? Okay, I have not given you the target sum.
It would
Target sum is
be.
4. Target sum is 4. Target
Oh,
sum,
okay. Yeah.
target is 4. Now, first, do not jump to the code. First, let's find the target sum is 4. What subarray has target sum of 4?
Target sum 4 would be 2 and 2.
Hmm.
It'll
Write it
be
down. Write it
2 and
down
2 has. Oh, okay. Yeah. So
because this is
3 and 1,
very important. 3 1.
and then 2 and 2.
Just separate these subarrays.
Oh, and then okay. Yeah. 3 and 1.
See these variations asked in Google as well. So this problem like that, these variations. Okay.
Okay. Then I guess -6, 6,
Negative 6, 2 and
2,
2.
2. I think I did, right?
Yeah. So which is the largest here?
Be negative 6, 6, 2, and 2.
Yeah, the last one, right? So we need to
Yeah.
return the length of that. Length of we need to return not the subarray. We can take another question. So return first is find the longest subarray and return the length.
Yeah.
Return the length. Another can be return the subarray. Return the subarray is more complex. Print the subarray. I can say print the subarray.
Okay.
So in that case, you need another data structure. You can use a list or something. Otherwise, how you can print that? You need a written that gives you that maybe another. We will come to that. Yeah, return length. First, we need to return length. Length is 4. You need to return that length.
Sure.
Yeah.
So
How can we do that? What's the naive approach?
the brute force approach.
Hmm.
So you can use 2 pointers,
2 pointers. Yes.
and
Like all
then
the
you
sub
just
problems we have done. I told you all subarrays has same brute force. Almost same brute force.
right, right. So yeah, you just do the same thing basically, 2 loops, and then you have a uh,
Hmm. You have to find all
again, and then you
subarrays.
just make the
Yeah, you have to find all subarray sums, and you have to compare with the target sum. You have to compare the target sum, right?
right.
And how you compare that is largest or smallest? Actually,
You
I
can
think
do
the brute force you need to write. Otherwise, you cannot understand. You need to return the
sure,
length.
right. So where do you want me to write it?
Yeah,
Right here.
you brute force one.
Yeah, yeah. So I'll just copy and paste this one for now, and then edit it.
Mm-hmm.
That's fine. Uh, where's I can't see the
1 minute. Length sub.
yeah. Oh, all right. So you copy paste this now for now, right?
Mm-hmm.
And then so K is the target sum, right?
Yeah, cut target sum.
Okay, so we'll do if curve sum equals K, then we'll do we'll make a variable for the we're looking for the max length, right?
Looking for the max length. Yeah, max length. For that, we
Sure.
need
So
a
we'll do
flag or counter to check that.
right, right. So we'll do int max one equals you can do integer dot max or something.
Yeah, integer dot
Or we
mean.
can do 0, I guess.
Integer dot mean. When you say max,
Oh, right, integer dot min, you're right. My bad. Is it
integer
integer is
dot mean
capitalized, right?
or yeah, it should be capital. Yeah, syntax is not correct.
Yeah. So integer dot
Mean value.
min value,
Yeah, yeah.
like that. Okay, so then if cursum equals k, then max len equals j minus I, right?
Plus one.
Plus one, right? Yeah. So and then wait,
Hmm.
no, wait. So you need
You're updating max length, but we need the max one. Means we need the
yeah,
longest.
yeah,
So we Only update if there is some longest you find. You find that.
Right. So we can do and max length is less than j minus I plus 1, right?
If that's greater than, not less than.
No,
Uh,
it should be less than.
yeah, yeah. Hmm. Hmm. If that is greater than the max length, then you are updating. Yeah, you can do that way, or you can do simply that way. Mm, Mat dot max of max length. Yes, sir. You can do both of them.
Okay, yeah, yeah.
Yeah, it is not correct. So yeah, that's the n square complexity.
Right.
We need a linear time complexity. Means we need a linear solution. Can you think about it? So I told you it's prefixum and prefixum uses hashing. Hello.
Yeah, yeah.
So hashing means I also told you in the last problem that what hash map gives us the advantage. What advantage it gives us?
Hash map advantage is the keys and values, right?
Yes. So we can store something in value. We can store something in the key.
Right.
Now here we are finding the length. So why not we are storing the index there? Because otherwise what we because lookup time is constant, and if we are storing the index there, we can simply subtract the index and find the longest sum.
Right.
Yes. Okay. So yeah. So you understand what I am saying? You have any doubt? Tell me.
No, I understand. I understand. Yeah.
So how hashmap works here? Uh, linear paper. Where is the diagrams? 1 minute. Line. Yes. So hash map has key and value. So key will be my array elements and value will be my index. Value will be my index. And now what we'll do? We again calculate the prefix sum if that. So the last condition only is the same condition for the last problem. So if we find something like that, if prefix some max here, we have to find the contains key, right? As I told you told me in that last problem. So why we are
Yeah.
not checking the contains key because that's a hash set. So here, if we contains key is present, then we simply take subtract that value. We subtract that what I say the indexes of the both subarray because in the hash map we store what we store we store basically the key as a number means the array elements and
Yeah.
value.
I can't really say anything right now. It says it has the time notification.
Oh, okay, let's some extend.
Okay, so then, right. So yeah. Let me just read this over real quick.
1 minute. Yeah, yeah. So here number of elements are, let's say, what's the example? Uh, 3 1, right? 3 1. Let's say one. And what we are storing here? Sorry, I missed that. So here in the map, we are storing the not the elements. We are storing the hash. Sorry, prefix sum. So
Okay.
it will be the 3 and 1. Okay. So
Right.
again, I am repeating. I'm telling it again. I think I missed that. Yeah. In the hash map, key will be the prefix sum, and the index will be means the value will be the index.
Right.
So you calculate that a prefix sum, you store inside before storing the map, you check if the prefix sum is already present or not. Means present or not, how? Because current prefix sum minus the target sum is present or not. If that is present, if that is present, we we what we do, we count, means we calculate the uh, like the, what I say, we subtract the indexes for current prefix sum and the previous prefix sum. How you find that? We have the contains key. We contains key gives you the index. Means sorry, contains key not. I am saying the get. We can simply do get and find the index and subtract the uh, keys there. Means indexes there to find the length. Yeah.
Right.
If any doubt, tell me.
No doubt.
Yeah. Can you write this then?
Yeah. So, 1 second. So I'll. Yeah, 1 second. I'll write this here as well, I guess. And then, you made it right in the code section, right?
Yeah, yeah, code section. You need any Yeah, I'm giving you the template. Let me write.
I can just write at the bottom here if you want.
Yeah, you can write the syntax. Yeah, the function
Yes.
template you write. The function gives you what? Function gives you the an array and a prefix sum like that. Sorry, target sum that like that. The last part.
Yeah. So right. So we can do map. Uh, map integer pre some map new. No, the pre some map. So put 0 1. Uh, 4 int I. That's the nums, and then
See,
pre sum.
1 minute, 1 minute. You have written this code. So here we can do that. You understand the logic behind this?
Yeah. So you're putting the value 0 with the
Prefix
length
sum
of
is
1.
zero. Initial, it's the what I say. It's the what I say. We are initializing the map with the prefix sum of zero and index of 1. Like that we have done previously. I told you two ways we can do that. Either we can do this, or we need another if condition to check inside. Two ways we
Right.
can do that. If you understand this, you have already written. I told you I need to explain. I thought I need to explain. Okay, that's fine.
Okay, I mean, then sums plus nums.
If sum prefix sum you calculated, if prefix sum equal target. Okay, no. If that map name what you have given, please sum map. Yeah, that's fine. If
okay,
map,
so
yeah, write it.
um,
You have to check the content. Means if map contains key, write it.
right, right. That's what. Yeah, so it's changing this. Since key
Like in set we
prefixum
do contain. We check contains. Here we check contains key.
prefixum minus target sum, right?
Huh.
Or minus k.
Minus k. A target sum which is given to you.
So then if it's there, right? We do we're returning the max length, right?
Yeah, you need to calculate the length here now.
Okay. Um. Um. Okay. So if you put prefixum map dot put
No, put is comes after. Okay, yeah.
yeah,
Huh. You are putting. Yeah.
right, and then we do j minus minus I plus one here, right?
No. You are storing in the map. You are storing just simply the index of I. Why you are calculating the length there? You just simply put I for that prefix sum. So
So
I
how do
will
you
current index.
right? How do you get the length then?
If that map is there, if map contains key is there, what we are doing? If map contains key,
Is the same logic
contains
as
key
the
is there. That means we have something already present in the map. Like in the two sum problem. Just think about that, right?
okay? Yeah,
Like the two sum problem. Now what you do? Just simply you can do. We need to take another variable. Which variable?
we can do max length again, I guess, right? Max length.
Yeah, int max length. Int max length. We need
So
to.
we do this again, right?
No, do not. That's not readable actually. Just remove that. Yeah.
Okay.
Need you write this way.
Oh,
Length.
math.
Math. Yeah. That's
Okay.
readable. More readable, right?
Right.
Sim max length. Now we have to think like how we need to check. I am
Right.
writing.
So
You need to think, and next day you can come with a intuition. Some map. It's the map name, right? So map. Oh, where is it?
we
Map.
get our default or
Get default is get I minus. Sorry. Sum is sum and minus key. Like that we have to do.
okay.
It gives you the index of that previous prefix sum. Okay. Better.
Right.
What you can do for now? We will discuss in the next class. This is very important. This is very important means this, if you solve this problem, all the prefixum problems means it's the basic fundamental of that, all the prefixums. Most of them means there are 20-25 problems are there, and all the means all the problems has this template only.
Right.
We need to change something there. So we you have used this one. You can do another thing here as well. I told you, if that map, when I map dot contains key, like that, map dot contains key of what, prefix sum minus k. No, 1 minute. If, sorry, not that, map dot, sorry,
All good. Yeah.
1 minute, map dot contains key prefix sum is k. Yeah, we can do like that also. We can do this condition, or you can simply put this condition. We need to discuss about that in the next class. This is very important. You have written this line, but it has many significances there. Okay, so for now, what you can do, you just simply dry run this code. Okay, you simply dry run with an example, and I need to discuss about this problem in the next class as well, because the same problem is there, which is there in the lead code, very important problem. So if you understand why you are putting these, why you are putting at the end, why not before the checking the condition, another, yeah, I given you the task. If you write this line before checking this if condition, is it always fine, or there will be some test cases will fail? So that is your task, and you just try run with multiple examples these problems. See, it seems fine, but after a few days you will, you you may forget the intuition. So better
Right.
practice more. And what is the home task? You need to check this put should be always before or end, is there any constraints is there or not, why you have written this statement. So dry run with an example, I will again discuss in the next class. Okay.
Okay. Yeah. Sounds good.
Okay then. Yeah, so weekends you are free this weekend?
Sorry, say it again.
Weekends you are free for the next
Y-
class?
Yeah. I can book for either Saturday or Sunday. I'll let you know.
Yeah, yeah, we can do that. Weekend I am
Yeah.
free also. Okay.
Sounds good. Yeah.
Yeah, yeah. Thank you. Bye. Have a good night.
Yeah. Same to you. Bye. Thank you.
Bye.
I think you have to end the class. Yeah.
Yeah.